is made up of regions and availability zones. Hold on, let me look for a more interactive AWS global infrastructure. There we go. All right, the global infrastructure. So let's quickly explore this page. So as mentioned, our global infrastructure is made up of mainly regions and availability zones. Regions, as you can see here, it's all over the world. Regions are essentially the geographic locations or sites where we build infrastructure. Okay? So we have regions all over the world that spans the whole world. Currently, we have 25 launch regions. And this number 25 is significant because this is the options. This is the amount of options that you have as to where you want to build your cloud-based systems. And you have the freedom to choose among these 25 regions. And you are not limited to just only using one region. Moreover, this number is not static. It's ever growing. We are still expanding our global infrastructure, and ideally, we would want to be adding regions every year. Just this year alone, we have set a goal whereby we want to add 6 new regions. As of today, year to date, we have already launched one out of that 6 regions. Okay? So this number is not stagnant as we are still growing, and ideally we want to be able to have regions across the whole world. But as of right now, you have 25, and this is also the amount of options that you have as to where you want to build your cloud-based systems. Now, within these regions, you have availability zones. One availability zone in a region is a collection of data centers. So an availability zone is not just one data center, rather it's a collection of multiple data centers. And each region does have multiple availability zones, which means that each region has multiple clusters of data centers. Now, the idea of these availability zones is that this component enables you to build highly available infrastructure in the cloud. These availability zones, again, in each region you have multiple availability zones, but not all regions have the same number of AZs. For example, in the case of North Virginia has 6 availability zones. Whereas if we go to Canada, or let's say Ohio only has 3 availability zones. So not all regions have the same number of AZs, but each region must have at least 2 availability zones. Now, the idea of having multiple availability zones in a region is so that these AZs are isolated with one another. They have their own network. They are on different locations. They are on different tectonic plates, floodplains. They have their own network and power grid, and so on. And the idea of this isolation is such that if one AZ happens to go down, it ideally should not affect the operations of other AZs within the region. And that isolated characteristics enables you to build reliable infrastructures in the AWS cloud. Moreover, although these AZs are isolated with one another, they are interconnected through low latency links such that inter-AZ communication is still really fast. Right? And lastly, our global infrastructure are made up of edge locations. Edge locations are our points of presence data centers all over the world who serves as our content delivery network whose main purpose is to deliver faster content faster to customers globally by bringing the data closer to far away customers. All right. So basically, that is the global infrastructure. Again, we will be reinforcing that, but again, it is made up of regions, availability zones, and edge locations. Now, as mentioned, regions, as of today, we do have 25 regions worldwide, right? So you have a lot of options. Now, when choosing a region, you want to be able to consider different factors. Factors such as compliance and governance requirement, the location of the region, whereby you want to be able to be as close to your end users as possible to bring them optimal latency performance. The available services in region and features also vary per region, as well as how we price services in every region are also different. Okay, so as mentioned, region must consist of at least two availability zones. One AZ is a cluster of multiple data centers, right? And the idea of having multiple cluster of data centers is that they are isolated with one another. And with that isolation, that enables you to build highly available systems in the cloud. Take advantage of that AZs by deploying multiple copies of your resources across multiple availability zones. Because if one AZ happens to go down, that will obviously make all the resources in that availability zone unhealthy and down as well. But if you have replicated your workload in multiple availability zones, this failure is isolated and you still have a subset of healthy resources running in another AZ that is able to handle the load and maintain business continuity by continuously serving your customers despite one AZ going down. So this is the recommendation, is to replicate your workloads across multiple availability zones, making your systems reliable, such that again, if one AZ happens to go down, you'll be able to fail over into the resources in a different availability zone in an active failover solution. Okay? If you want to get closer to your customers, for example, in relation to the coffee shop, let's say your coffee shop is a hit locally and it's now known worldwide. Okay? So it's now known worldwide, and your customers will be flying to the country just so they can consume coffee from your coffee shop. Well, obviously, since now you are aware that you are serving customers globally, one good idea is to make franchises of your coffee shop in different locations so that you are able to bring the coffee shop closer to your customers. And similarly, you have that capability in AWS with our CloudFront service. CloudFront is our content delivery network as a service that leverages the points of presence data centers, which is our edge locations. The idea of CloudFront is that, or rather, the benefit of CloudFront is that it is able to deliver content faster to customers globally by caching the data into these edge locations. So, how does this work? Let's say, for example, we are hosting a streaming or video on demand application like Netflix, right? So we have a lot of videos that customers are consuming or watching, and these videos are stored in one region. Let's say, for example, in Brazil. So we have videos in Brazil, and we are serving customers globally. Without edge locations or without CloudFront, in order for this customer far away to consume the video, they would need to download the video, which will traverse from that customer's location to the region as to where we're storing the videos. And in most cases, this data journey, is quite long, meaning that it will incur latency overhead. And we want to be able to improve this latency performance by shortening the data journey. Hence, this is where the edge locations come in. With edge locations, our end user's request will be redirected to the most closest or the most optimal edge location. And that redirection will check if the data that is being requested for is available in the edge location cache. If it's not available, then we would need to pull the data from the origin server, and after that initial request, your data will not be cached or temporarily stored in that edge location, such that subsequent requests for the same data can now be served from that edge location. And because now you have drastically shortened the data journey, that will also drastically improve the latency and the responsiveness of your application. All right. So in order for you to take advantage of these edge locations, you would need to configure and enable the CloudFront service to deliver content through these edge locations. And the last thing that we'll be discussing that is really a service, but it's also related to infrastructure, would be AWS Outposts. So in order to understand the benefit of Outposts, again, let's reference back to our coffee shop, right? Let's say we have a coffee shop that is being visited by customers from different offices, right? During lunch break, customers would need to leave the office, go to the coffee shop, and order the coffee. Once they get their order, they may go back to the offices. So the problem here is that we are needing the customers to leave the office, incur travel time, which will reduce their break time, just to consume our coffee. Okay, so that's the issue that we are looking to tackle. Customers leaving their office and deducting break time because they are incurring this travel time going to our coffee shop. So instead of forcing our customers to leave the offices and go to our coffee shop, why not build a small branch of our coffee shop inside the office? That way, customers would not need to leave the office, but both of these coffee shops are still connected. All the transactions will still be reflected on the main coffee shop. The benefits can still be redeemed and also be reflected on the main coffee shop. Inventory will be retrieved from the main coffee shop, and the customer's data are still available in the main coffee shop. So essentially, we are bringing the coffee shop inside the office so that the customers would not need to leave their office premise, right? They would not need to leave, and they would not need to incur that travel time. And the idea of building a small branch or coffee shop inside offices in the cloud would be AWS Outposts. AWS Outposts extends AWS infrastructure by creating a mini region inside your data center. Okay? So you essentially have AWS infrastructure and capabilities in the comfort of your on-premises data centers. And AWS Outposts are ideal for workload that are time and data sensitive. And if you want to perform your workload strictly inside your data centers. So this is how we bring AWS to you, right? With AWS Outposts, we are building a mini AWS infrastructure, a rack of AWS infrastructure inside your data center. Okay, so just to quickly review the AWS global infrastructure, essentially it is made up of region, and again, region is essentially the global the geographic locations or sites where we build infrastructure. And these regions is also where you build systems in the cloud. Currently, you have 25 options, right? Where you are free to choose among those 25 and use multiple regions. Okay, and this number is not stagnant as we are still growing our IT footprint, our global footprint. Now, within each region, it consists of at least 2 availability zones, but do note that not all regions have the same number of availability zones or AZs. These AZs, one AZ is a cluster of data centers. It's a collection of multiple data centers, right? And these AZs are isolated with one another. They are isolated with one another in such a way that if one AZ happens to go down, it ideally should not affect the operations of other AZs within the region. And that isolation allows you to design reliable systems in the cloud by replicating your workloads in multiple availability zones within the region. By the way, this replication is something that you would need to configure and set up on your own. This is not an automatic or built-in feature by default, right? This is something that you have the option to do or not do. If you're looking to do so, this is something that you would need to set up and configure on your own. In addition to that, since you are replicating your workloads in multiple availability zones, that will also increase your expenses. Essentially, it will multiply based on how much you replicated your workloads. Okay? Now, although these AZs are isolated with one another, they are interconnected through low latency links, such that inter-AZ communication is still really fast. And finally, we have edge locations. And edge locations serve as our points of presence data centers, which act as our content delivery network, which through Amazon CloudFront, you'll be able to bring content closer and faster to customers worldwide to improve the latency and the responsiveness of your application. Okay, so now that you've understood the concept of the global infrastructure, you are now able to start to build systems in the cloud. And if you're looking to interact with AWS services, we do provide you with different channels. Because like in a coffee shop, you're able to do a lot of stuff like ordering a cup of coffee, asking for a refill, checking your reward balance. In AWS, you're also able to perform a lot of actions, which includes launching an EC instance, creating a load balancer, invoking an AWS Lambda function, and all of these actions are interfaced by an API front. And in order for you to invoke these APIs, we do provide you with different channels. The AWS Management Console is an easy to use graphical interface that you'll be able to access over the browser to interact with AWS. The AWS Command Line Interface or the AWS CLI leverages on your applications or your computer's command application. And each operating system does have their own command application, but essentially you'll be able to use that to send commands to AWS. And finally, the software development kits or SDKs are programming libraries or package that you import so that you'll be able to programmatically interact with AWS. Okay, so the SDKs are now supported in common programming languages like Python, C Sharp, Java, Go, Ruby.NET, and so on. Okay, and with that, that effectively concludes our discussion on Module 3, whereby we have understood the AWS global infrastructure, which consists of regions, availability zones, and edge locations. Regions are the sites or the locations. And we have also discussed the different factors that you would need to consider when selecting an AWS region as to where you want to build your systems. In regions, you have multiple availability zones, and we also understood that because of the isolated nature, AZs allows you to design reliable systems in the cloud by replicating the workloads across multiple availability zones within the region. And finally, edge locations serve as our content delivery network. Finally, when you are looking to build systems in the cloud, there are three ways for you to interact with AWS services, and that would include the management console, the command line interface, as well as the software development kit. And with that, that concludes our discussion for Module 3.